Today we got the SAMA5D4 Xplained board. It uses the Cortex A5 microprocessor, and today we will create a C project for it, and we will put it in the internal SRAM because the program will be quite small, so it will fit there. So let's get started with creating the project. So the environment for the project is the IAR Embedded Workbench, and we will click Information Center, Example Projects, and from the list we have to download the microchip, which I already did, and from the list we have to select the microprocessor unit examples. So getting started, and from the list we select our device, and let's select the default folder. Okay, so I got the Xplained board. So from the build options I select the Xplained board with the option of SRAM. Okay, so let's take a look at the main file. So as we see, we got the uart configured for the board, and it's connected to the debug. And also we got some LED blinking, which is also controlled by the user button. Okay, so now let's just try to compile the project. Okay, so now we need to locate where we got the build of the whole program. So we need to take a look where we got the binary file. So let's go to the location where we got the project, and we will select the getting started, board build, explained SRAM X. Oh, and it's not there because we got to click make. Okay, so now we got it. So that's our file, which we will copy next on to the SD card or the NAND flash. So the first option I will show is to download it into the SD card. So let's just copy this right here and name it boot binary. Okay, so now let's unplug the SD card and put it into the board. Okay, so in order to boot from the SD card, we need to put the SD card into this slot, which uses the MCI1. And the slot up here is the MCI0, and it doesn't boot from there. It works everything fine, you can access the card right here, but it won't boot from it anyway. And also I got a boot from NAND flash closed, so it's right now in the Samba monitor. So now let's click reset, and we will boot from the SD card. Okay, so it's doing a blink example, and also it prints out some information on the debug port, which is this port. So let's now replug it. Okay, and now let's take a look what we got printing. Okay, so I got the debug port selected, I will open it, and now I'm resetting the board. Okay, so we have a log which we could see in the main file, so the name of the program and some additional information. Okay. Also, we can check if the user button works. Okay, so it stops printing and also stops blinking, and it resumes. Okay, so let's modify this example a little bit. Okay, so we will add to the project ADC support. I've made a few functions for this. Let's go to the documents and let's copy my functions into our project. So that's drivers, and let's put it into peripherals. So let's copy those two files, put it right here. Okay, and now let's add it in our project. Let's add the C file. So we need to add the ADC.C. Okay, and now let's go into the options of the project, and we have to add a few includes. So C compiler, preprocessor, and we got our files added into a folder, which is this. Okay, but also we have to add a file which has the includes for the registers, and that's located in program files and embedded workbench, and we have this in the includes. So we search for the microchip and let's find a word. And we need the instance for the ADC. So this path we will copy and add it to our includes. Okay. Now let's go to the edit file and let's add those functions for initialization. Oh, okay, so I also have to add the includes at the header. Okay. Okay, let's see if it finds it. Yeah, so it still has problems at finding it. So let's just go back to the project and let's add the file path manually. because it's probably not this folder, which is already in the include files, but it's probably somewhere around here. So let's go back, drivers, peripherals, and let's copy this. Okay, now let's put it right here. Okay, and let's try that again. Okay, sorry, my bad. For some reason I just copied one file. So that's why it didn't find. Okay, so let's do that again. Yeah, I copied the wrong file right here. Yeah, let's add the missing one. Okay, fine. We got those two. So now it will work 100%. Yes, finally it did. Okay. Now going back to our adding the ADC. So we got the init and now let's configure a channel. So below the init, let's configure channel 0. For this board you can select a total of 5 channels from 0 to 4. So let's select 0. Okay. And now in the main loop we will trigger a ADC conversion on the LED toggle right before it, and let's read the data from it into a variable. Let's call it response, and we got read from a function, and let's print it instead of the 0. So let's add a sprint of our variable into decimal, and don't forget to put a new line and our variable. Okay, let's try to compile it. Okay, so that works. Okay, now I will show you a different method of putting the program into the non-volatile memory, and we will put it into the NAND flash. So in order to do that, we will need the SAMA. So I've got the program already located in the users and the user profile right here. And I've got the script copied from the examples, and it is this script, and I modified in this script that it only writes the boot binary file, and the binary file is located in the same folder. So let's change the boot bin file into our new created one. So we get to build, explained, SRAM, and we copy this one, this file right here. So let's delete the old one. Let's paste it, rename it. Okay. Okay, so now let's run the command prompt, and let's go to the Samba folder, so cd sam pa. Okay, so let's check if it works. Okay, so it prints out the help. Okay, so now let's put the board into the Samba monitor. Okay, I changed the colors for a better look. So let's do that again. So cd sam a. Okay, working. So now let's go to the board. Okay, so now I'm going to put the board into the Samba monitor. So I'm removing the SD card, and now let's have this jumper closed. Put reset. Okay, and now we need to re-enable the NAND flash. So let's remove the jumper. Okay, so now let's take a look at our Samba monitor. Okay, so we need to type in Samba X and our name of the QML script. So it's NAND USB QML, and let's click enter. Oh, because we got the board wrongly connected, so let's. Okay, so the jumper is closed, and let's connect the USB, the Samba monitor, and let's re-enable the NAND flash. Okay. Okay, let's do this again. So the command, and it opened the available COM port, and it's erasing now the memory from the NAND flash from the 0 address to the last one. It takes a while because it's quite big. And we got our program in the NAND memory. Okay, so now let's take a look at the board. So as we click reset, it goes to the program from the NAND flash right here. Okay, so now let's replug the USB to the debug. So we will be able to see the UART print. Okay, so we got our serial port. Let's select the debug port. Okay, and we got the ADC value printing while that is making a blink. So thanks for watching. See you in the next one.